Hi guys, so that's me back with another video on different examples of like resonance stability and all. Now let's try to solve few examples related to stability of resonance structure. Now let's try to understand what are the parameters on which we are going to decide. The first criteria, this has to be the sequence. Okay, first has to be neutral, then it has to be complete octet, then you have a pi bond, more number of pi bonds, then negative charge on electronegative atom, positive charge on electropositive atom, same charge should be as far as possible, opposite charge should be closer. Okay, now let's say if you have any series wherein one is neutral molecule and other is complete octet, then you would definitely choose neutral molecule. Okay, let's say if you have a choice between neutral molecule and pi bonds, then neutral molecule. Let's say if you have a complete octet and charge, then you would choose complete octet first instead of charge, right? Now let's try to see this example. So give the order of stability of the following resonating structures. So if you could see, these are the resonating structures which are given to you. Okay, so this is 1, 2 and 3 order of stability. Now if you could see here, negative charge, negative charge, negative charge, that means all are negatively charged. So the first rule is not possible to be applied. The next is complete octet. If you could see here, oxygen with a negative charge has 8 electrons, right? Okay, similarly carbon with a negative charge, again 8 electrons. Okay, and then you have nitrogen with a negative charge. So if you could see, nitrogen is connected to hydrogen. It already has one lone pair, but there is one additional lone pair, right, because of which it has got a negative charge. And if you could see, this nitrogen is connected to hydrogen and there is a bond with this particular framework. So again you have nitrogen surrounded by 1, 2, 3, 4, 5, 6. Okay, and then you have 7, 8 electrons. So even octet is complete for nitrogen. So second rule is not applicable here as well. Now let's talk about more number of pi bond. 1 pi bond, again you have 2 of them. So definitely this is going to be the least stable. Okay, this is going to be the least stable. Now let's talk about these two, right? More number of pi bonds. So when you talk about these two, let's see what exactly is going to be the next parameter. So now you got more number of pi bonds. Now let's talk about the negative charge. So negative charge should be an electronegative atom. So if you could see here, between carbon and nitrogen, nitrogen is more electronegative, right? So between these two, third is going to be highly stable, right? So the order, this is going to be highly stable, this is going to be least stable. So the order of stability has to be third, okay, and then you have second, and then you have first. Okay, so this is basically the order of stability. So now let's talk about another question. Which of the following structure is more stable? So if you could see here, positive charge, so definitely they are not neutral. Next, more number of pi bond, that solves the entire logic, right? But before that, there is one more thing, complete octet. Now let's try to see this. Carbon with a positive charge. So if you could see, this carbon is connected to 2 hydrogens and then a bond, right? So, and a positive charge. So 3 bonds, each bond contains 2 electrons. So 1, 2, 3, 4, 5, 6 electrons here. So this is incomplete octet. Okay, and if you could see here, positively charged nitrogen with 2 hydrogens and 2 bonds, this makes the total to be 4 bonds, right? 4 bonds means 8 electrons. Okay, so this is nothing but complete octet. So if you could say, 2 is stability of 2 is more than 1. This is very, very simple to understand. Okay, so now let's move on to the next question. Okay, so you have been given the resonance structures here. All are canonical structures, obviously. Now let's try to see. Positive charge, positive charge, positive charge. That means all are positive. So they need to be neutral. If any one of the structures could have been neutral, it could have been very easy. So all are positive. Now more number of pi bonds. This contains 1 pi bond, this contains 1 pi bond. Okay, so that means structure 2 is going to be the least stable, right? Now let's try to decide between these two. So if you could see here, what is the next? So first is neutral molecule, then you have Complete octet, yeah. So let's first see the complete octet, right? Same number of pi bonds, so it's pretty much simple. Neutral, then you have complete octet. So if you could see nitrogen, again 4 bonds, complete octet. Oxygen is again complete octet, right? So I could simply prove this as well because there is one lone pair over here. Okay, so this oxygen is connected to a hydrogen, and then there is a double bond and there is a positive charge. Obviously there has to be one lone pair, right? So 3 bond means 6 electrons, 6 plus 2 8. So octet is complete here. Again the octet is complete here. Now let's come back, more number of pi bonds. Okay, yes, very good. So now if you could see here, the fourth rule is negative charge on electronegative atom. So if you could see here, electronegativity of oxygen is greater than electronegativity of nitrogen, right? So that means nitrogen should carry the positive charge because it is less electronegative, and oxygen should carry a negative charge. So the structure wherein nitrogen carries a positive charge would be more stable. So 3 is going to be more stable, right? And then you would be having 1 and the next is going to be 2. Okay, so let's try to see. This is the particular answer for this particular question. Okay, so this was about few examples on resonance and their stability.